Hello, everyone. Thank you for coming today. This event is brought to you by Data Talks Club, which is a community of people who like data. And we host regular events. And today is one of these events. We'll talk about model monitoring. Next week, so we usually have these meetings like that every Tuesday. It's more like technical discussions. So this week we'll talk about model monitoring. Next week we'll talk about, the title is still not clear. It's been discussed, but it will be about deploying a chatbot. And then the week after that, we will talk about the feature store called Feast. We also have a different kind of events on Friday, which are more like a discussion, like live podcast without slides. It's less technical. And this week on Friday, we will talk about a role called developer advocate for data science. Then the next week, we'll have two events. So one on Friday, like usual, and one not on Friday, on Tuesday. We will, on Thursday, sorry. We will talk about open source on Thursday, and we will talk about MLOps. What is MLOps on Friday? And all the questions you have today, you can ask through Slido. So if during the talk you have any question, if you want to ask it, just go to this link. I will paste it to Zoom chat. And now I will. Now Emeli will start. So Emeli, before she starts, let me just quickly introduce her. So Emeli is a co-founder and CTO at Evidently AI, which is a startup that develops tools for analysis and monitoring the performance of machine learning models. And today she will talk about what they do at Evidently AI and in general about model monitoring. So please, Emeli, start. The floor is yours.
Thank you so much for such a nice introduction. I'm going to share my screen now. Hopefully it's shared yet, right? Can you see it?
Yes.
Perfect. So once again, hi there. I'm really happy to be here today and share with you our thoughts about an analysis and monitoring of machine learning models. My name is Emeli Dral. I'm CTO at Evidently AI, and prior to that, I spent like 7 years helping companies from different industries, varying from banking to manufacturing, to use machine learning and deploying some production services on top of machine learning models. So this basically means that my talk today will be more practical than academic. So we all know that training useful machine learning model is a complex task by itself, and deploying it into production is its own challenge. But unfortunately, even if we do this, the work doesn't stop, because a lot of different things can happen with machine learning model, which is already in use, and all this failure, they cost even more because model is already in production, it generates some business value, and each failure costs something. So to account to it, we first of all need to know about the problem, and we need to figure out that something is happening with our model. And let me just show you some examples of these kind of issues and show what can actually happen to the machine learning model. And there are a lot of different things that can go wrong. And first is data, because in most cases, when something is wrong with our model, it's because the data is wrong. And first example is data processing issue. For example, we can have some broken pipelines, or maybe someone can move source file and we can lose an access to it. And this case, of course, will break our model. And the second example is data schema change, and this is the really big one, because, for example, our machine learning model can use the systems like CRM as a source data, and the CRM users can, for example, rename a couple of columns or move it around, and such changes seems really normal and harmless for these users, but such changes can break our model if this model uses such CRM system as the input data. And this can happen actually not only with internal data. If you use some third-party data or external APIs, this also can happen. So data loss as another example. For example, we can have data loss because of some physical sensors breaks, or for example, the login can be implemented incorrectly. And of course, all these issues will lead to some problems with our machine learning models. And finally, when we have some complicated architecture of models, for example, when one model uses output from another model as a feature, and something goes wrong with the first model, then all others will suffer, of course. Even if everything is okay with our data, there still can be some problem. The second is data drift, and this is the change of our data, and it can be changed in data distributions. Let's imagine the situation when we work on some online service and we have different users coming from many different channels. For example, we can have users coming from some social media, some users coming from paid search, or maybe others channels. And one day we can figure out that, for example, we have a lot of users from Facebook instead of users from paid search. And in this case, our model can start degrading because it's just haven't seen such users during training period, and we just need to demonstrate to our model these segments of new objects, and because we need to like make our model understand how to work with this new segment of objects, and maybe we need to retrain the model. And even if the data isn't changed, there still can be some concept drift. This is the case where our data stay the same, but our target somehow changed. For example, we can take some online service, or we can take an example with some churn prediction, right? And in this case, we can train model and during the training see that the churn rate for users from paid search has some specific level, but when we apply our model, after some time, we can see that, for example, churn rate for a specific segment, for example, for paid search, is increased. This can happen, for example, after some marketing campaign or other changes in the world. But in this case, our model can start degrade because there may be new patterns that we haven't learned yet, and we need to demonstrate this new pattern to our model. So we can just retrain our model on the new fresh data set, or if world is changing too much, we might need to like rebuild model entirely. And this concept drift can be different. For example, it can be gradual. This is the case where our changes accumulate over time. And in this case, just simple retraining can help, because we can just calculate, for example, the speed of degrading during the training, and then just schedule regular retraining. Or this drift can be sudden, and this is something that's really hard to miss. And recent pandemic is a perfect example of such concept drift. But we do not always need a pandemic to face sudden concept drift. For example, it can be some application update or some equipment failure. And in this case, we can see such concept drift really quickly. So, okay, now we see that a lot of things can happen with machine learning model, and the question is how to prepare to it. It's really often happens that, for example, we learn about our problem from our users, or face that our machine learning model doesn't work only a few weeks later. Unfortunately, this is still happening, and the only answer for it is monitoring. We need to analyze logs of our model from time to time to see if models still work correctly. So one can say, okay, but you have production services for ages, why cannot you just take the same practice and reuse it for machine learning models? Well, there is some truth to it. We definitely can do this, but here we have not only code, we have a lot of data here, and this adds some additional layer of complexity. So we definitely need to set up some service health monitoring. We need to monitor things like uptime or memory usage or latency, but we need to add some additional metrics like model quality, data drift, and other stuff, because the more pipelines, the more moving pieces we have, the more complicated monitoring we need to set up. And FICO recently performed research where they asked enterprise companies, do they monitor their machine learning models? And they figure out that most companies just don't do this. And I'm really interested if you guys monitor your machine learning model. This is the statistics for now, and this tells us a lot about this topic. So before we go into the details of what to monitor, what metrics to look at, I want to quickly bring up the point about infrastructure, right? And here I will assume that you already have some production services, and your machine learning model will not be the first service you're about to monitor, because if it is, then probably you should pay more attention about infrastructure to use and setting up the basic service health monitoring. But if you already have some services in production, then I would suggest to reuse the existing infrastructure. For example, you can use something like Grafana for logs. I mean, for example, Prometheus for logs storing, and Grafana for dashboarding and for alerts. And if you start monitor your machine learning model, you can just reuse the very same architecture, but you might need to start logging more and to add some more specific alerts and specific scenarios for your machine learning models. And one more thing is that you might have only batch models. In this case, you can use simpler architecture. I mean, for example, you can use BI tools like Tableau or Looker to analyze your machine learning models from time to time, because these tools are, they are simple, they are easy to use, let's put it like this. They are more flexible, and this can be a perfect start to analyze and monitor your machine learning models. But definitely these tools, they do not cover the real-time case, so be careful with them. But anyway, they can be really nice start. So, okay. Now we are moving to the discussion of the particular setup of monitoring, and I suggest us to be pragmatic, because there are a lot of different metrics we can monitor, and the question is, do we really need to monitor all of these metrics, and do we really have resources to calculate and analyze all of them? So I suggest to tackle this problem like step by step. And to do this, let's consider three important factors. First is use case importance. This basically means how important is your problem. The second is service complexity, because, well, batch is different from real time, right? And the more different pipelines you have, the more complicated monitoring you need to set up. And your resources, of course, because to set up comprehensive monitoring, you need to have some resources to create and support it. So let us pick a use case to use it as an example. And I suggest us take the regression problem. This is the task where we need to predict the demand for a public bicycle rental system. This is a well-known data set. You can basically go and download it from UCI repository, and yes, it is in Google as well. So I believe a lot of you guys saw this data set before. And I suggest us to go layer by layer. And as I said before, the first monitoring that we need to set up is basic service health monitoring. So the first question is, does our system actually works? And service health monitoring will help us to understand this. And here again, I assume that you already have some setup, so I won't talk about it much. Just the only thing that makes sense to add is the model calls. This is a metric that shows us basically how much calls do we have for our model, because sometimes the software can still work, but the machine learning model does not. For example, if you have some fallback system that can answer instead of your machine learning model if the model does not, then you can see on all other dashboards that everything is working, but this model calls metric will help you to understand that maybe there is some issues with machine learning model. Okay, when we are sure that our model is responding something, this is a good moment to measure model's quality. So there is two questions we are interested in. First, how our machine learning model performs, and second is, did anything break? Because if everything works, then we can just go and do other interesting stuff. But if something is broken, then we need to dig deeper and figure out what is happening. And for model performance monitoring, we can also calculate a lot of different metrics, but I would like to start from the situation where you do not have the feedback for our model immediately. It can happen for some use cases when, for example, you generate some forecasts, but the prediction horizon is really long because, well, if you are trying to predict the demand for 1 hour in advance, for example, then in an hour later you will have the correct answer, and it's pretty simple to calculate metrics like accuracy score or error rate or something like this. But if, for example, you generate some predictions for a month or for a year, then it's rather complicated. And I know that a lot of analysts prefer just wait until you have some feedback and then calculate some quality metrics, but there are a lot of different things we can figure out using just our model output. For example, we can check the output distribution and see does this distribution meet our expectations. For example, we can have some very strict expectations on our distribution. For example, we can want this distribution be within the specific ranges, or maybe we want it to stay like lower than something, some threshold, or upper than some threshold. And all these things can be checked without any feedback, right? Or maybe we want our distribution stay normal with some specific mean, and this actually also can be checked without any feedback. It's even better when we have the distribution from the training phase where we trained our model, because in this case we can compare our production distribution of output with the distribution that we had during the training. And well, yes, these distributions shouldn't always be the same, but if they differ, it's better to understand why and have some clear explanation, right? So there are a lot of things that we can analyze even without some feedback. It's much easier when we have some more data. I mean, if we have some data from the training phase, it's always good to use it to compare from the production. And if we have some feedback, it's much easier because, well, yes, if we have some feedback, we can easily calculate any quality metric you like, for example, error rate or accuracy score. But here I only suggest to pick the right quality metric really accurate, because it's really important when your quality metric tells you really directly what's going on. For example, because, well, if you have a binary classification problem with unbalanced class and you use accuracy score, you know what can happen. If there is some problem with minor class, then you can just miss it because accuracy score will be still high. So to avoid situations like this, it's better to pick quality metric correctly. And I also suggest from time to time, take a look at the error distribution. for at least for one quality metric you have, because this year distributions will help you to see what is happening with your model from a larger perspective. And you can see, for example, that you can check if your distribution is still symmetric to 0, or model started to underestimate or overestimate your target function. And the last but not least one is the business metric, because technical team is not the only team who needs to be informed about model performance. It's always good to sit together with your product or business specialist and try to figure out how the model's quality connected with the business KPI, with the business quality, with the business metric, and come up with some suggestions or ideas about some business metric we can calculate on top of our prediction. For example, in these cases, we can figure out that we need to keep our error rate lower than some threshold, for example, lower than 100 of bikes, and we can just publish the error rate to everybody. So managers will be able to keep an eye on model quality and alert you if something goes wrong with the model. And here, before we move to the third part of monitoring, I want to quickly demonstrate your tools we are working on. This is the open source tool called Evidently. It's now on GitHub. And if you, for example, have no feedback for your model, or if you already have one, it's even easier. You can go and check model quality. So now I will change my share and show you Jupyter Notebook. I believe this is very popular tools, and a lot of data scientists use it for, at least for experiments. And here I want to show how you can quickly account for model quality and generate report using Evidently package. So let me just import some standard libraries like pandas, numpy, and scikit-learn, and I will also import two models from Evidently. So this is dashboard and drift tab and numeric target drift tab. So then I will read the data set. This is a bicycle rental data set. I will show the preview of this data set. So this is, I believe, a lot of you guys recognize this one. And let me split our data into two parts, because as we discussed before, it's always good to compare your production data with data from training phase. And here I will just simulate it using the one data set. So more earlier data will be reference data and data from training stage, and more second part of data will be like production data. So let me do this. And I will create some mapping dictionary to show to the tool where is prediction. So I will say that count, this is the actual amount of rented bike. So I will tell my model that this is my prediction, and I will show where is date time. And numerical features and categorical features, just features that we have in this data set. So this is pretty simple mapping, and I can generate dashboard here. I just pass to my dashboard reference and production data, column mapping, and I tell that I want to have a numeric target drift tab. So I run it, and after it generated, I can show it inside of Jupyter Notebook. So it's loading now, and it looks like this. So with help of this tool, we can compare our output models output distribution from training phase to production phase. So here I have production in red and reference, which is training, in gray. And we can easily see, for example, that if we split our data into production and reference like this, then distribution will be really different. Of course, we see that range is different. So during the training, we saw only pretty low demand, and during production, we have different example, low and high demand for bike rentals. And there are some more visualization. This is the correlation. If you're interested, you can analyze the correlation between features and your output, and just see how these values look during the time. So we can see that this is where we trained our model, and this is where we use our model in production. So we can expect some problems because, well, yes, models during production, our model haven't seen the examples of high demand. But if our model can approximate values really well, so maybe this can work. For example, linear models sometimes can handle this, but I'm not speculating about model because I don't have one for now. I'm just demonstrate how it can look. And yeah, there is one more thing here. This is the table with the plots of prediction and features. For example, we can open fields like temperature and see how our output depend on feature and compare it. For example, here we can see again that during the training, we saw only examples with demand from 0 to 300, but during production, you already have a lot of examples with higher demand. So this is how we can detect some problems with our model on early stages. But okay, let's go back to our monitoring and discuss what else can go wrong with the model. Yeah. So using tool like Evidently, or maybe you can plot such visualization yourself or use other tools, we can figure out and so when something goes wrong with our model's quality. But the model quality is the very good indication of some problem with model. But when we see that model's quality dropped, we do not know immediately why it dropped, right? So we need to figure out where exactly our model breaks and where to dig further. And here data quality and integrity can help as well. So here I suggest to analyze the data that we use as an input data for our model. And there are a lot of different ways to check if something went wrong with the data. For example, you can accumulate statistics or features that you have and calculate the rate of missing data, or you can go and do it feature by feature. But sometimes it's really complicated to analyze and visualize it if you go for an option feature by feature, because for larger data sets, it can be like hundreds or even thousands of features. To solve it, I suggest to use aggregated statistics and analyze only key drivers for your model if you know what features are the most important. For example, you can figure it out with help of some feature imported analysis techniques and analyze only these features in more details. And I also suggest do not limit your analysis only on missing data, because there are a lot of important things you can analyze. For example, some range violations, if you have some expectations on the range for your feature, or feature types mismatch, and so on. With range violations, it's sometimes complicated because, well, our feature can still stay in the expected range, but already be broken. For example, imagine the situation when you have some physical sensor, for example, temperature sensor, which is the feature for your model, and you have some expectations. For example, the temperature should be from 0 to 100 Celsius. And our physical sensor can breaks and always shows, for example, 100 Celsius. And in this case, the range won't be violated, right? Because it's still within an expected range. But our model can be already confused with this feature, especially if this physical temperature sensor is really important for our model. And to figure out such cases, we need to conduct very complicated analysis. I mean, we need to analyze individual feature distributions. We need to compare some multivariate feature distributions on subsets of important features. So this really takes some time and effort. And here again, I have a very pragmatic approach for it, which is feature correlations. Of course, we all know that linear correlations can help us see only linear dependencies between features, but if feature behavior is changed, then there is a solid chances that we will see it when we analyze linear correlations, right? So what I suggest us to do here is to take our key drivers and see the correlations between features on the training set. Then during production, we can again take these key drivers and calculate correlations for production phase. And then all we need to do is to compare this correlation between each other. And for example, here in this plot, we can see that correlation between temperature and feels like temperature with month during the training was positive, and during the production, it became negative. Here it's very straightforward because, well, we specifically selected data this way. So we trained our model during summer, and we applied the model during autumn and winter. So this correlation has changed. But there can be more complicated cases, and this simple analysis really helps to see that some feature behaviors has changed. And finally, if everything is okay with our data, the data drift and concept drift can still happen. And the data drift and concept drift both are not that straightforward to calculate, but here is again a very pragmatic approach. I again suggest us to look only at key drivers and to see if there is some data drift or concept drift. You can just check feature or target distributions and compare it to each other. For example, we can use some statistical tests for features depending on feature type and feature distribution. For numerical feature, we can use Kolmogorov-Smirnov test or Anderson test to check if the distribution has changed statistically. Or we can use some visual analysis because, well, sometimes you can see that there is some pattern, like feature start increases, or there is some non-linear trend, right? And such things you can figure out visually even faster. So here's an example with feels like temperature feature. Again, you already know the answer, so we can check this help of statistics or visually that the value of our feature has changed, right? And this is something that you also can do with help of a tool we are working on now. So I can quickly show how it will be looking at evidently dashboard. So we are coming back to our Jupyter Notebook, but now we will use another kind of report. So if before we used numerical target drift tab, now we are going to use just drift tab. This is the data drift. So again, I generate the drift dashboard. I pass here reference data set, production data set. Now I do not need column mapping really because I'm not interested in target drift. I need to calculate data drift for my features. So I just run it and I can show it in Jupyter Notebook. So there is some statistics for data drift. We have a lot of drift features. This happened before we split the data set this way, right? And we can go for any features, for example, again for temperature, and see how it looks like, right? So temperature increased significantly and we see that it's above the expected value. Or we can go for some other feature and see how it looks like. For example, count, which is our target, and we again can see that it has changed a lot. And one more thing, if we have a lot of features and maybe we need to share this report with some other people from our team, then we can generate some HTML report. So we need to call method save, and then I can just open it in my browser. So it's opening, I believe, and we can have the same dashboard as HTML file and easily share it, for example, via email with our team. Yeah, so this is how we can calculate data drift and account for it with help of evidently package. And this will help us to figure out if our data changed and maybe we need to retrain or rebuild our model. So summing up, I just demonstrated to you a very pragmatic approach to monitoring, where we start from service health and ended with data and concept drift. But there are a lot of more things that make sense to analyze if we work with some specific and complicated cases. For example, it's makes sense to estimate quality not only on the whole data set we have, but for specific segments. For example, where we have pretty wide audience and we are interested in different audience segments, right? And if, for example, your model works in healthcare, then model bias or fairness is very important. If, for example, you run model to predict some credit score, you might be particularly interested in finding some outliers to send them into manual review. Or if you, again, have some service for a wide users audience, it might make sense to generate a layer of explainability because it helps to improve user experience and generate some trust to the system. And so I just demonstrated how we can decide on what to monitor depending on the available resources and use case complexity and importance. And here I want to warn you only about one danger zone where you have a very important and complicated case and you're running out of resources to build complicated monitoring. This is the really danger zone because sometimes costs of errors can be very high. And in this case, I believe it makes sense to first set up a comprehensive monitoring. So this is pretty much all I want to share with you today. I want to thank you for your time and for your attention. And if you guys have some questions or maybe comments, I will be happy to discuss it. And I want to also mention that my co-founder Elena is also here, so she can take part in discussion and answer some maybe product or market questions.
Thank you. So we do have quite a lot of questions in Slido, and for everyone, so just want to remind you that there is a link in Slido in chat. You can go there and check. So I first I want to ask you, so as I understood from the demo, that this tool is something more like for offline use, but can it also integrate, let's say, with something more real time? Or this is something we run, like we use this tool maybe in our batch job that would generate these reports and then we will use them? Or how does it look in production?
Thank you for this question. This is very nice because currently we have only this library, which is much better to use in batch mode, right? Because you can, for example, schedule this regular job and generate these dashboards, right? But we are working on the service when you can have some connectors and connect it to your database to have these dashboards and reports in real time. But for now, it's not available. We are working on it. This library will be backend for this service.
Okay, clear. I want to share my screen because we have a lot of questions in Slido.
Okay.
So,
oh, now I can see it. Perfect.
And yeah, you can see them.
Sure.
So the Kirill is asking what statistical test does this tool run under the hood in this data drift report?
Yeah, sure. Good question. So we have several statistical tests here, and depending on feature type, we choose it. So now we have Kolmogorov-Smirnov test, which works for numerical features. And we have a chi-square test which runs for categorical features. And we are adding more because we want to add Anderson test for numerical features too. And when it comes to categorical features, everybody knows that there are a lot of different limitations, right? For example, we cannot really run chi-square test when we have categorical features with only a few different values, like lower than 5, right? And in this case, for now, we still unfortunately run chi-square test, but we are in our next versions, we will change it.
Okay, thank you. Then that's an interesting question. You shared some statistics with us that 67% of companies do not monitor their models. And do you have any idea why they don't do? Is it because it's too difficult or because they don't see value, or maybe you have some other ideas?
This is really good questions. And to be honest, I do not have a really good statistical answer to it. I can share only my opinion. And based on my experience with different companies, I believe it happens because, everybody have service health monitoring, and a lot of people just wait until the first huge mistake happens, and only after it happens, they started to worry about the model quality issues.
Yeah, but it's also like a chicken and egg problem, right? If you
Yeah,
don't have monitoring, how do you know you have problems, right? So
actually,
maybe they actually do have problems, they just don't know about them.
maybe only after you start really losing a lot of money, then you might
Yeah.
solve it. Yeah.
That's the next question is really funny. So yeah, I don't know what do you think about this? Like, how does evidently package hold against the European GDPR regulation about data confidentiality? So,
So here I help, and I will help with the right answer.
Let me jump in here. So can you hear me, guys?
Yeah, sure.
yes.
So
Hi.
my name is Elena, and I'm Emeli's co-founder. And actually, the question is very valid, and we have an easy answer to it because the tool is open source. So you can use it, and you can run it however you want in your own infrastructure. So you don't really need to transfer data elsewhere. And actually, this is one of the reasons why we wanted to start with open source, because of course, if you do it as a service, there's like a lot of things to walk through and to prepare so that it actually fully compliant with regulations.
Yeah, thank you. Um, what is the best way to track metrics with a long and different response? For example, user churn, where the same day forecast result can be checked only in a few days, weeks, or months.
Yes, this is a good question. It's really relevant for a lot of forecasting systems, right? Where you don't have, for example, immediate feedback, or when you have different horizons for your model. And here, I believe for early stage monitoring, you can use the approach I demonstrated, like an analysis of models output. It's especially good when you have some specific expectations on it. For example, you know how, for example, from historical data experiments where you had all the answers and all the correct values, you can have some expectations how your model's output should looks like when you have a good model. And I think very promising approach is compare your current production model's output with some output you expected to have for a good model. And if it differs a lot, then probably it can be indirect signal of some problems, but it's not guaranteed, of course. So yeah, that's a tricky situation.
Yeah, it is indeed. Thanks. Is it possible to integrate the evidently package with Tableau to monitor to have this dashboard directly on Tableau?
For now, unfortunately not, because we only generate this visualization in Jupyter Notebook or in HTML, but we do not have any raw data out imports, right? But this is the hypothesis we have, so maybe I'm not sure yet, but maybe we will generate some output that will be compatible with other visualization tools. This is very possible.
Yeah, because I guess Tableau is something that companies uh, usually have, Tableau or some other tools, and it will
Yeah, this is very
help
nice.
to integrate. Then Kirill has another question. So there is a problem with this Kolmogorov-Smirnov test. It will always show that data comes from different distribution if sample is too large. Do you somehow handle this problem?
This is a very nice question, because this is actually kind of common problem for many different statistical tests, right? And I mean, it's the problem for hypothesis testing as well, because if you have really a lot of data, then you will start finding some differences, right? At some point, at least. So this is not implemented yet, but evidently we'll handle this problem definitely. So we will first we are going to choose the most suitable test for each feature individually. So not only based on the feature type, but based on the distribution and feature statistics we saw. We definitely will let users choose the specific test if, for example, user really wants to calculate some specific test. And we are going to create the functionality that will calculate some specific subset of the data set to calculate tests. It is also very important when you have the larger data sets. For example, when we're talking about some thousands or like maybe millions of rows, for these cases, we definitely will need to have some subsets and calculate tests on top of subsets of data.
Okay. Thank you. So what is your product and your business? So I don't know.
I'm showing my face
Hi.
so that I can answer this. So actually, there are a lot of companies that are doing business on top of open source projects, and there are a lot of examples. Even Grafana that everyone is using for service monitoring is actually a business because there's an enterprise version, Mongo, GitLab, you name it. And we plan to do exactly that. So we plan to build an open source project first, and on top of it, some enterprise-focused offering. Because the idea is that there are some things that maybe only large companies need, or that are maybe mostly needed for managers and the business users that we can kind of layer on top of it. And that's the goal. But from the beginning, we actually first want to build a good enterprise project, or good open source project, and to make it popular and adopted. And so we're happy to actually see your comments of what you would like to see. So this thing is free. You can use it for now and give us feedback.
And probably this one is also for you. Bridge is asking, does Evidently provide consulting services to organizations willing to incorporate monitoring with
let's talk. So you can contact us. There is nothing systematic yet, because literally you see like most of the company right now, excluding Alexei. So yeah, so we're pretty small and just starting up. We can discuss this.
Do you have any idea how to monitor and check multi-arms bandits?
Oh, I love this topic personally, so yeah, thank you for this question. It's definitely not implemented yet, but we have some ideas for multi-armed bandits. We have some ideas for recommender systems, so to make it wider, right? Because there are different very interesting techniques that can be used for recommender system. I believe this multi-arms bandit can be connected with recommender system, but it can be not. I'm just speculating here. So I cannot promise like when, but we are going to have something for multi-armed bandits too. Like, yeah.
Mm-hmm. Thank you. Then, what is the median lifetime of a model? Median breakdown time?
Good question. It really depends on the use case, and it depends on how often we call this model, right? Because it can be, for example, a case when you have a batch model that you run like once a quarter or once a month. And in these cases, it's can be like more often than you run this model, right? But if you have something that works in real time, it can be like every day, right? So it's really hard to answer, but I would say that at the very beginning of the production usage of the model, there will be a lot of some problems, breakdown, but after, let's say, first maybe week or some first period of production work. Generally, these cases are stabilized. You probably will have some good fallback system where, for example, you, if you do not satisfied with the answer that comes from your model, you switch to another system, maybe some physical models or maybe some analytical models, I mean, without any machine learning, or maybe even some static answers. And after, let's say, first iteration, in most cases, it's became more or less stable. Of course, if data changes a lot, or you have concept drift, or maybe some new patterns, then yes, model quality will degrade. But when it comes to some huge breakdowns, it's in most cases stops like after first couple of runs.
Yeah, thank you. So which machine learning algorithm, in your opinion, require relatively straightforward or relatively complicated monitoring? Does it even matter like which algorithm we use?
Let's say like this. It's a good question because I'm trying to answer shortly. It really depends on the use case, because let me just bring here an example. If, for example, you're modeling something for a very stable domain area like physics, where, for example, we had a use case in the company where I worked before, where we created some recommendations on raw material usage for metal smeltings. Right, so this is the process when you can, which you can describe with help of physics, and this more or less stable process. So if you use any machine learning model for this process, this will be more or less stable, because you know, the whole entire features are stable, because like the temperatures, the humidity, the results of chemical laboratory analysis will be in more or less expected ranges, and in this case, model will be more or less stable. But when you have some use cases which are connected with some real users who can generate some unexpected queries, for example, or behave somehow unexpectedly, then these models definitely need a lot of monitoring, like, let's say, from the very beginning. So I would say it's mostly dependent on the use case and on the input data. And yes, when it comes to algorithm, even if you have very complicated model architecture, I mean some deep neural network or some I don't know what can be more complicated here. For example, some gradient boosting or combined approach. When you analyze your model on historical data and you make sure that model works, so during the production usage, you actually do not like retrain model if you do not retrain model, right? So this is the stable software, and the model itself will be more or less correct. What you really need to monitor is the data and the pipelines. This is the most important things. So I believe it more depends on data, on the implementation of pipelines, and on the use case and its stability.
Yeah, thank you. So then another question we have, where does the product, I probably think it assumes evidently package, where does it excel? I can generate those automated reports with some custom cron jobs.
I'm showing my face just in case you want me to take it. Yeah, so actually, first of all, the product right now is obviously like just early in the stages, so it doesn't cover like the whole thing that we want to add. But the general idea is that even if you want to generate these jobs yourself, you have, for example, you need to decide like which test to use for which feature to estimate data drift, how to actually implement it, and generate these visualizations, right? Just to do this thing, it will also like take you some time. The second is because we will be adding this report, so we just started with this data drift, target drift. Right now we're working on model performance validation reports and so on. The idea is that it's comprehensive and available basically out of the box. So you just choose what you want. You don't have to code this all. So just for the reporting purposes, you can also easily share them with other users by sending this HTML to someone, because it can be generated and saved externally, which is very helpful in our own experience. Basically, I was asking as a product manager from Emeli a lot. So the idea is that it's easy to generate. We thought for you, basically, what you might need to look at. You don't have to think this through, and we implemented all these tests. So they are like, you don't have to code this on your own. And after that, when we come up with the full monitoring service that you already asked, Alexei, and Emeli mentioned that we work on it, the idea is that it can actually work as a service. So you can connect it and you will get these reports and alerts for you. So you don't have to set it up from the very beginning. Just like any tool, you can do this homegrown, or you can take and implement someone else's.
So basically, as I understood, so like you can have these custom cron jobs, but just in these custom cron jobs, you call this evidently package instead of using your own tool, right?
Yeah, for now, yes.
Does data drift necessarily mean low quality model? Wouldn't all reports give warnings in COVID times?
Not necessary. I mean, the model can use a lot of different features as an input data, right? And if there is some drift detected for features which are not that important for models, I mean, which are not key drivers, for example, then the model quality can not degrade, right? And model cannot suffer too much from this data drift. But now the tool implemented in a way that we analyze data drift separately for each feature. And in this case, yes, report will tell you that there is a problem for each feature. And it will, yes, give you some warning in the COVID times, but to be completely honest, during COVID, I believe you would figure it out faster without any tools, because like I believe all the quality metrics and business KPIs will show you that something goes wrong.
Yeah, probably if your monitoring doesn't say something is wrong, then you have bad monitoring. I mean, during COVID times. Right. Okay. What kind of additional features can we expect from this package in the near future?
Oh, yeah, we are working on a new part of the dashboard, let's put it like this. And right now we are working on model validation. So it will be implemented for the regression problem for classification problem and for probabilistic classification, right? So this will be a new part of evidently. And this is something that will be implemented in the near future, and we have more long-term plans to create more tabs. So I believe Elena can help here.
Yeah, so the immediate one that will be released next is this model validation, and just not to confuse it with like cross validation or just like backtesting. The idea is to basically show how your model performs now compared to how it performed in training, just using the usual metrics and also showing the segments of lower performance, or somehow helping you to identify where a model is performing worse compared, for example, to where it performed before, and some ideas around that. And then basically we have like a list of other things that we want to add that help you to understand your model behavior from different angles. So kind of like expanding the set of these reports, and also creating a service eventually. So in the immediate future, you will probably test this validation if you want in the next month. But later on, the vision is that you can use it as a service if you wish for real-time monitoring.
Yeah, we're actually running out of time. Just do you have time, Elena, Emeli, to take more questions?
I think so. 5-10 minutes, sure.
Yeah.
Okay, thank you. So when after a detected data drift, is it better to retrain the model or change the model class family and restart the machine learning pipeline?
This is a super nice question. Thank you for it. It really depends on, as always, I believe guys usually don't like my answers because I always say depend and depend, but that's true actually, because, well, in most cases, when you detect data drift, you might not have enough data to retrain your model. So you start detecting the new behavior of some features, but you do not have enough data to really retrain the whole model. So the first thing I could recommend here is to somehow calibrate your model, maybe come up with some post-processing or some calibration techniques that will slightly change your existing model to account for these changes. And later, when you accumulate more data, then yes, it will be better to retrain model. And if let's put it like this, if we see that there are a lot of features drifting and these features are pretty important to your previous model, then it makes sense to run a couple of experiments and you can still stay, for example, within the same algorithm family, right? But the hyperparameters can be different. For example, if you will see that there is a lot of variation in your newer features, I mean, the variation increases a lot, then probably you might have, for example, more trees in your random forest, right? Or things like this, or maybe higher coefficient of regularization in your linear model. So sometimes it makes sense at least to run some hyperparameter search over your newer data set to make sure that you cannot achieve better models quality with this simple retraining. So I always suggest to run some experiments after you have a sufficient amount of new data.
Okay, makes sense. Thank you. What kind of challenges have users of the library faced when using it?
For now, actually a lot, because it's even not stable version, it's dev version right now. But the first challenge is that if you have a really huge data set, like let's say 1 gigabyte or even more, then our HTML report will be pretty huge. This happens because we do not implemented the service yet, right? And we store all the data inside of this HTML report, so the file can be really big. This is, I believe, the biggest issue we have right now. And the other issues are like minor, because it's in most cases connected with some features that are not implemented yet, but will be soon, or maybe less soon, depending on the feature.
Mm-hmm. Thank you. Can you give any recommendation, like what kind of data sets people can use to experiment with your library, in addition to this bicycle data set?
I believe if you have table data, it will suit here. So it doesn't work for now with any images or video or music or text, right? But for tabular data, it will work. So it really can work with a lot of different data sets. So definitely any standard data set that you can load from scikit-learn datasets model, or you can load from UCI repository, but yeah, any tabular data.
Mm-hmm.
Add to this, there are basically 3 more examples in GitHub that you can check out specifically for our tool.
Yeah.
Okay, thank you. And how many people are creating evidently?
You see them.
So just you two, right?
Yes.
Do you have any other contributors to the library already, or still?
One more guy.
Oh, okay. Okay, good. And yeah, I think Kirill asked 3 questions today. Thank you, Kirill, for the questions.
Mm-hmm.
Emeli, thank you for your speech. Our director is curious. Is it?
It is safe.
Yeah.
You can just download this and run it on your own premises. So no data is transferred anywhere. We don't log anything. So it's just free for you to use.
Yeah, and it's open source. So if you have some security department in your company, they can check the whole source code. It's not that huge, and make sure that everything is okay.
Okay. Well, thank you very much for your talk. Thank you very much for staying a bit longer to answer the questions. That was pretty interesting. So thanks, and please share the links, the links to the slides, the link to the repo. I will put everything to Slack. And yeah, thanks a lot.
Yeah, thank you so much for your time. I really appreciate it.
Yeah, thanks. So goodbye.
Bye, everyone.
Bye.